Here is the first question asked in March 2014. Find the angle between these two given lines. First line and second line. So we know that the angle between two lines r vector is equals to a1 vector plus lambda times of b1 vector and r vector is equals to a2 vector plus mu times of b2 vector is given by cos theta is equals to modulus of b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. So to identify the angle between given two lines, we need b1 vector and b2 vector. And the vector b1 is obtained by comparing this first line with this given first equation of line. So in place of b1 vector we have I plus 2j plus 2k. Therefore b1 vector is equals to I plus 2j plus 2k. Similarly, b2 vector obtained by comparing this second given equation with the standard form. So in place of b2 vector we have 3i plus 2j plus 6k. Therefore b2 vector is equals to 3i plus 2j plus 6k. So now we got the both required vectors b1 vector and b2 vector. So to identify the angle between these two given lines, we need b1 vector dot b2 vector and magnitude of b1 vector, magnitude of b2 vector. So now what? b1 vector dot b2 vector is equals to b1 vector is I plus 2j plus 2k dot b2 vector is 3i plus 2j plus 6k and dot product of two vectors obtained by multiplying the corresponding coefficients I with I, j with j and k with k. Therefore, b1 vector dot b2 vector is equals to, so in the first vector coefficient of I is 1, in second vector coefficient of I is 3, therefore 1 into 3, 3. Similarly, plus 2 into 2, 4 and 2 into 6, 12. Therefore, b1 vector dot b2 vector is equals to 12 plus 4, 16, 16 plus 3 is 19. So finally, b1 vector dot b2 vector is equals to 19. And then we need the magnitude of b1 vector. So now what? Magnitude of b1 vector, which is equals to square of the I coefficient, that is 1 square is equals to 1 plus square of j coefficient, 2 square is 4 plus square of k coefficient, 2 square is 4. Therefore, magnitude of b1 vector is equals to square root of 4 plus 4 8, 8 plus 1 9, which is equals to 3. Similarly, magnitude of b2 vector is equals to square root of 3 square 9 plus 2 square 4 plus 6 square 36, which is equals to square root of 36 plus 4 40, 40 plus 9 49 and square root of 49 is equals to 7. So we got b1 vector dot b2 vector, magnitude of b1 vector and magnitude of b2 vector. Now use these three values in the cos theta. So therefore, cos theta is equals to modulus of b1 vector dot b2 vector is equals to 19. So 19 divided by magnitude of b1 vector is 3 into magnitude of b2 vector is 7. Therefore, cos theta is equals to 19 divided by 21. Hence, theta is equals to cos inverse of 19 divided by 21, and which is the required angle between the given two lines. I hope all of you understood. Now let's start the next question. And the next question is, find the direction cosines of a line which makes the equal angles with the positive coordinate axis. So this question asked in the year 2017, March 2017. So here we need to identify the direction cosines of line which makes equal angles with the positive coordinate axis, means OX axis, OY axis and OZ axis. So here we need to identify the direction cosines of the line which makes equal angles with the positive x-axis, y-axis and z-axis. See here, let's suppose this is a x-axis, y-axis, z-axis. Observe here, this is a positive x-axis, positive y-axis and positive z-axis. So he has given that there is a one line which makes equal angles with the x-axis, y-axis and z-axis. So let alpha is the angle made by the line L with the positive x-axis, and beta is the angle made by the line with positive y-axis, and gamma is the angle made by the line with positive z-axis. According to the question, according to question, he has given that this line makes equal angles, means alpha is equals to beta is equals to gamma. So now the direction cosines of the line, let's suppose direction cosines of the line is L, M and N, and we know that the relation between the direction cosines of the line, that is what, L square plus M square plus N square is equals to 1. And if alpha is the angle made by the line with positive x-axis, then the value of L is equals to cos alpha, and beta is the angle made by the line with y-axis, therefore M is equals to cos beta, and gamma is the angle made by the line with z-axis, therefore N is equals to cos gamma. So by this relation L square plus M square plus N square, we also rewrite it as L square means cos square alpha plus M square means cos square beta plus N square means cos square gamma is equals to 1. And in this question, he has given that alpha is equals to beta is equals to gamma. Therefore, the above equation can be written as cos square alpha plus cos square alpha plus cos square alpha, because alpha is equals to beta is equals to gamma. Cos square alpha plus cos square alpha plus cos square alpha is equal to 3 cos square alpha, which is equals to 1. Hence, cos square alpha is equals to 1 by 3. Therefore, cos alpha is equals to 1 divided by root 3. And this is the value of L, because L is equals to what? Cos alpha. So we got the value of L, and similarly the value of M is equals to, the value of M is equals to cos beta, cos beta, and we know that beta is equals to alpha, so we may write it as cos alpha, and the value of cos alpha is 1 by root 3. Similarly, the value of N is cos gamma, value of N is cos gamma, where gamma is also equal to alpha, therefore N can be written as cos alpha, therefore the value of cos alpha is 1 by root 3. Hence, the direction cosines of the given line is 1 by root 3, 1 by root 3, 1 by root 3. Hence, direction cosines of given line are what? 1 by root 3, 1 by root 3 and 1 by root 3. I hope all of you understood. So let's start the next question. And the next question is, show that the lines, first line and the second line are perpendicular to each other. So here we need to prove that these two given lines are perpendicular to each other. And this question asked in the year June 2016. See here, to prove that given two lines are mutually perpendicular to each other when their Cartesian equations are given, so then definitely if two lines are perpendicular, the sum of product of their direction ratios is equal to 0. So that is what, if suppose A1, B1, C1 are the direction ratios of the first line, and A2, B2, C2 are the direction ratios of the second line, if these two lines are perpendicular to each other, then definitely A1, A2 plus B1, B2 plus C1, C2 is equals to 0. So to prove that these two given lines are mutually perpendicular to each other, so we need to identify the direction ratios of first line and as well as direction ratios of the second line. See here, to identify the direction ratios of the first line, compare this first line with the standard Cartesian equation of line. That is what? X minus x1 divided by a1 is equals to y minus y1 divided by b1 is equals to z minus z1 by c1. So by comparing this first line with this standard equation of line, the value of a1 is 7. So now what? Direction ratios of first line. So let's say A1, B1, C1, where the value of A1 is 7 and the value of B1 is minus 5. Similarly, the value of C1 is 1. And to identify the values of A2, B2, C2, compare the second line with the standard form, that is x minus x2 divided by A2 equal to y minus y2 divided by B2 equal to z minus z2 by C2. To identify the values of A2, B2, C2, compare this equation with the second given equation of line. So in place of A2 we have 1 and in place of B2 we have 2 and in place of C2 we have 3. Therefore, direction ratios of second line, let's say A2, B2, C2, where A2 is equals to 1 and B2 is equals to 2 and C2 is equals to 3. So to prove that these two lines are perpendicular to each other, so let us consider LHS of the condition of perpendicularity. Let us consider LHS of the condition of perpendicularity. So now substitute the value of A1. Value of A1 is 7 into A2 is 1 plus value of B1 is minus 5 into B2 is 2 plus value of C1 is 1 into C2 is 3. So hence 7 into 1, 7 plus into minus minus 5 into 2, 10 plus 1 into 3 is 3. So which is equals to 7 plus 3 is equals to 10 minus 10. So finally we got 10 minus 10 equals to 0. It means A1 A2 plus B1 B2 plus C1 C2 is equals to 0. Hence Hence, given two lines, given two lines are, are perpendicular to each other, are perpendicular to each other. I hope all of you understood this question. So let's start the next question. And the next question is, find the shortest distance between the lines. In this question, we need to identify the shortest distance between these two given lines. Let's say this is a first line and this one is a second line. See here, in both the lines, the direction vector is same. It means the given two lines are the parallel lines. And we know that the shortest distance between the two parallel lines, let's say r vector is equals to a1 vector plus lambda times of b vector, and r vector is equals to a2 vector plus mu times of b vector, is d is equals to modulus of b vector cross a2 vector minus a1 vector divided by magnitude of the b vector. So to identify the shortest distance between two parallel lines, we need a1 vector, a2 vector and b vector. So here by comparing the first line with the first standard equation of line, in place of a1 vector, we have I plus 2j minus 4k. So therefore, a1 vector is equals to I plus 2j minus 4k. And in place of b vector, we have 2i plus 3j plus 6k. So b vector is equals to 2i plus 3j plus 6k. Similarly, for a2 vector, compare this second given line with this standard equation of line. So in place of a2 vector, we have 3i plus 3j minus 5k, 3i plus 3j minus 5k. Now see here, to identify the shortest distance, we need what? A2 vector minus A1 vector. So now what? A2 vector minus A1 vector. So one more thing, this question asked in the year July 2015. See here. Here A2 vector is 3i plus 3j minus 5k and A1 vector is I plus 2j minus 4k. So A2 vector minus A1 vector means 3i minus 1i, which is equals to 2i, and similarly 3j minus 2j, which is equals to 1j, and similarly minus 5k minus into minus plus 4k is equals to minus k. So we got A2 vector minus A1 vector, that is 2i plus j minus k, and then we need B vector cross A2 vector minus A1 vector. Now what? B vector cross A2 vector minus A1 vector is equals to determinant of first row is a unit vector I, j, k, and second row is the coefficient of I, j, k in B vector 2, 3, 6, 2, 3, 6, and third row is coefficient of I, j, k in A2 vector minus A1 vector 2, 1, minus 1, 2, 1, minus 1. So hence B vector cross A2 vector minus A1 vector is equals to. So already you know that method of solving the determinant. Plus minus plus. So I into deleting first row first column 3 into minus 1 minus 3 minus 1 into 6 is 6. Then minus j into deleting first row second column 2 into minus 1 minus 2 minus 2 into 6 minus 12, and similarly plus k into deleting first row third column 2 into 1 2 minus 2 into 3 is 6. Therefore B vector cross A2 vector minus A1 vector is equals to I into minus 3 minus 6 is minus 9 minus j minus 2 minus 12 is minus 14 plus k 2 minus 6 is minus 4. Hence B vector cross A2 vector minus A1 vector is equals to minus 9i minus 9i minus into minus plus 14j plus into minus minus 4k. So we got the required B vector cross A2 vector minus A1 vector, and also we need the magnitude of B vector. So ಇಲ್ಲೇ ಮಾಡಿ ನೋಡ್ರಿ. Now what? Magnitude of B vector. Now what? Magnitude of B vector is equals to square root of 2 square is 4 plus 3 square is 9 plus 6 square is 36. So which is equals to square root of 36 plus 4 40, 40 plus 9 49, and square root of 49 is 7. So hence magnitude of B vector is equals to 7. And now use this B vector cross A2 vector minus A1 vector and magnitude of B vector in this formula. So therefore D is equals to modulus of B vector cross A2 vector minus A1 vector is minus 9i plus 14j minus 4k divided by 7. So hence D is equals to, so magnitude of this vector is square root of minus 9 square is 81 plus 14 square is 196 plus minus 4 square is 16 divided by 7 as it is. Therefore required distance between the two given lines D is equals to square root of, see here, 196 plus 16 plus 81, 6 plus 6 12, 12 plus 1 13, 10 10 plus 9 19, and 1 plus 1 2. So D is equals to square root of 293 divided by 7 units is the required shortest distance between these two given lines. I hope all of you understood. So now let's start the next question, and the next question is find the shortest distance between the lines. In this question also we need to identify the shortest distance between the two given lines. Let's say this is a first line and this one is a second line. So observe here the direction vectors of both the lines are different from one to another. It means these are the skew lines. So and we know that the shortest distance between two skew lines r vector is equals to a1 vector plus lambda times of b1 vector, and r vector is equals to a2 vector plus mu times of b2 vector is d is equals to is d is equals to modulus of b1 vector cross b2 vector dot a2 vector minus a1 vector divided by magnitude of b1 vector cross b2 vector. So this is what formula to find the shortest distance between the skew lines. And one more thing, this question asked in the year March 2017. See here, to identify the shortest distance between these two given lines, we need a1 vector, a2 vector, b1 vector and b2 vector. So to identify the a1 vector and b1 vector, just compare this first given line with the standard equation of line. So by comparing, in place of a1 vector, we have I plus 2j plus k. Therefore, a1 vector is equals to I plus 2j plus k. And in place of b1 vector, we have I minus j plus k. I minus j plus k. b1 vector is equals to I minus j plus k. And for a2 vector and b2 vector, compare this second given line with this second equation of line. So in place of a2 vector, we have 2I minus j minus k. Therefore, a2 vector equals to 2I minus j minus k. And similarly, in place of b2 vector, we have 2I plus j plus 2k. So b2 vector is equals to 2I plus j plus 2k. So we got the required a1 vector, b1 vector and a2 vector, b2 vector. So now we need to find the required values. So required values are a2 vector minus a1 vector. First we need what? a2 vector minus a1 vector. Now what? a2 vector minus a1 vector is equals to, where a2 vector is 2I minus j minus k and a1 vector is I plus 2j plus k. So a2 minus a1 vector, 2I minus I is equals to 1I, and similarly minus j minus into plus minus 2j. So minus j minus 2j is minus 3j, and minus k minus into plus minus k. So minus k is minus 2k. So finally we got a2 vector minus a1 vector, that is I minus 3j minus 2k. And then we need b1 vector cross b2 vector. Now what? b1 vector cross b2 vector is equals to determinant of, first row is the unit vectors I, j and k. Second row is coefficient of I, j, k in b1 vector. 1, minus 1, 1, 1, minus 1, 1. And third row is coefficient of I, j, k in b2 vector. 2, 1, 2. 2, 1, 2. Therefore, b1 vector cross b2 vector is equals to, b1 vector cross b2 vector is equals to I into, deleting first row, first column, minus 1 into 2, minus 2, minus 1 into 1, 1. Then minus j into, deleting first row, second column, 1 into 2, 2, minus 2 into 1, 2. And then plus k into, deleting first row, third column, 1 into 1, 1, minus 2 into minus 1, minus 2, minus into minus plus 2. So therefore, b1 vector cross b2 vector is equals to I minus 2 minus 1 minus 3 minus j 2 minus 2 0 plus k 1 plus 2 is 3. Hence, required b1 vector cross b2 vector equals to, hence required b1 vector cross b2 vector is equals to minus 3I and then minus 0j, then plus 3k. So this is what required b1 vector cross b2 vector plus 3k. And then we need the magnitude of b1 vector cross b2 vector. Now what? Magnitude of b1 vector cross b2 vector is equals to square root of minus 3 square 9 plus 0 square 0 plus 3 square is 9. So which is equals to square root of 9 plus 9 is 18, and 18 can be written as 9 into 2. Therefore, magnitude of b1 vector cross b2 vector is equals to, see here, square root of 9 is equals to 3 into root 2 units. So therefore, we got a2 vector minus a1 vector and b1 vector cross b2 vector and its magnitude. So to identify the shortest distance between the lines, just use these values in the formula. So d is equals to modulus of b1 vector cross b2 vector is minus 3i minus 0j plus 3k minus 3i minus 0j plus 3k dot a2 vector minus a1 vector is I minus 3j minus 2k. I minus 3j minus 2k divide by magnitude of b1 vector plus b2 vector is 3 root 2. Therefore, d is equals to distance d is equals to modulus of minus 3 into 1 minus 3, 0 into minus 3 0, then 3 into minus 2 minus 6 divided by 3 root 2. Therefore, d is equals to, therefore d is equals to, see here, modulus of minus 3 minus 6 is minus 9 divided by 3 root 2. So here I can cancel 3 ones are 3 threes are. Therefore, d is equals to, therefore distance d is equals to modulus of minus 3 divided by root 2. Therefore, d equals to modulus of minus 3 is plus 3 divided by root 2. So to cancel square root in denominator, do the rationalize here. So d is equals to 3 by root 2 into root 2 divided by root 2. D equals to 3 into root 2, 3 root 2 divided by root 2 into root 2 is root 2 square, then square get cancelled 2. So hence the required distance between the two lines is 3 root 2 divided by 2 units is the answer. I hope all of you understood.